In this video, I'm going to solve the question maximum distributed tree. This is from the Codeforces round 665 of division 2. In this question, we have been given n nodes of a tree and therefore it's going to have n minus 1 edges since this is a tree, and we are asked to find the maximum possible distribution index. Now the distribution index of a tree has been defined using this function f, which is basically the sum of numbers on the simple path from node U to node B. So what we have to do is, if we have been given a graph over here and we have been given a tree over here and we want to allocate numbers to each of these edges such that we obtain the maximum possible distribution index. Now the value f has been defined such that it's the numbers is the sum of numbers from U to V. So let's suppose this is 1 and this is the third node. So and this edge has a number, let's say 10 on it, and this is 20. So f of 1 comma 3 is going to be equal to 10 plus 20, that is 30. Now the distribution index is nothing but the sum of all the possible f values over distinct pairs. So we'll consider all the paths that are there and we are going to find the f values and then sum it up. We have to follow certain rules in this. We have to allocate the numbers on the edges using certain rules that have been given. So these are the rules. Each of the integers on the edge must be greater than 0. The product of all the n minus 1 numbers should be equal to k. Now this k is going to be of the form of its prime factors in the input. So we can use that. We don't have to prime factorize it during the program. And the number of ones among all n minus 1 integers must be minimum possible. Now let's try and first understand how we can allocate numbers that have already been given to us to maximize the distribution index. Let's suppose this is the tree that has been given and these are the numbers that we want to allocate on the edges. So what should be the sequence in which we allocate these numbers? Okay, the first thing that we should understand is the function f is equal to the summation of edges along a path. So and the distribution index is going to be the sum of all the f values for each of the pairs. Now if we can find how many times an edge is being used, we can allocate these numbers easily. For example, this particular edge over here is common to 5 of the paths. So the paths are from this to this, this to this, this to this, this to this, and this to this. So it's basically 1 multiplied by 5 nodes. So for any path we can find the number of times an edge is going to be used. Let's take an example for this particular edge. So we have 2 nodes over here, we have 4 nodes over here. So we can say that whenever we want to travel from any of these nodes to any of these nodes, we have to take this particular edge. Now whenever we are trying to take this edge from, so the total number of times that we take this edge is going to be 2 multiplied by 4. So the value of the hit index of this edge, I like to call it the hit index, is going to be equal to 2 multiplied by 4 equals 8. Similarly, we can find for this edge it's going to be 1 multiplied by 5, which is equal to 5, and So we found that this is 5, this is 8 because 2 into 4. For this it's going to be, for this particular edge it's going to be 3 multiplied by 3, that's going to give us 9. For this edge it's going to be 5 of these and 1 of these, it's going to be 5. And for this edge also, since it's a leaf, we can say that it's 5. It's going to be 5. Let's use different color. Yeah. So these are the hit indices. Now what we have to do is, we want to find the distribution index. Since this is going to be hit 9 times, whatever index, whatever value we are going to assign to this edge is going to be multiplied 9 times to give the distribution index value. So the answer is going to be, let's name these edges. This is E1, this is E2, E3, E4 and E5. Now these are the edges. So the answer of the distribution index, the distribution index is going to be 5 multiplied by E1 plus 5 multiplied by E3 plus 9 multiplied by E2 plus 8 multiplied by E4 plus 5 multiplied by E5. So now it's kind of intuitive that we should allocate the maximum value to this edge E2, then to this, and then since all are same, we can allocate in any manner. So what we should do is, E2 gets the value first, that is going to be equal to 5. Then E4 gets the value, and the value is going to be 4. E1, E2 and E1, E3 and E5 all are going to get the value 1, 2, 3 respectively. We can place them in any order. It's not going to change our distribution index. So this was the idea behind the question. Now there's another part to the question where we have to use the number k to find the numbers that we want to actually allocate to the edges. Now let's consider, coming to the last stage of this problem, we have k in the form of p1, p2 till pm. Now we have to distribute numbers in the edges such that the value of the product of these numbers is going to be equal to k. Now let's consider 3 cases that we should consider to solve this kind of problem. So the first case is where m is equal to number of edges. In this case, what we should do is, we allocate the numbers p1, p2 till pm to the edges. So we sort these numbers and we multiply it to the sorted value of the hit indices and sum them up, and that's going to be the answer. Now in the second case, when m is less than the number of edges is n minus 1, so let's consider that m equals to 7 and n equals to, let's say, 5 and edges equals to, number of edges is equal to 7, let's say, and let's say that the value of k is equal to 2, is the product of these numbers. In this case, what's going to happen is, since we have only 5 prime numbers and 7 inches to allocate the numbers to, so we are at a lack of factors of k that we can allocate. So what we are going to use is 1. So any difference that this has, here the difference value is 2, so we are going to use 2 ones to satisfy the problem. So these are the values that we should use to allocate the problem where m is going to be greater than n minus 1, and let's say m is equal to 5, the number of edges is equal to 3 in this case, and let's take the same example as the previous one where the number k is the product of 2, 3, 5, 7 and 13 prime numbers. So let's take 3 edges E3, E2 and E1, and let's let these be sorted according to their hit indices. Let the hit index of this be 30, this be 20, and this be 10. Just for the sake of an example, I'm going to do this. Now, since we want to have the product equal to k, we are going to have to use all the prime numbers that are given, allocating the numbers from the lowest possible one. So I'm going to use 2 for E1 and 3 for E2 and 5 for E3. Till now the distribution index comes to be the sum 5E3 plus 3E2 plus 2E1. Now, since we are left with 7 and 13, where should we put this? Definitely, since this is the largest index, definitely since this edge has the largest value associated with it, we should place 7 and 13 over here. So this becomes 5 into 7 into 13. This is 3 and this is 2. So the distribution index for this case is going to be 2 into 10 plus 3 into 20 plus 5 into 7 into 13 multiplied by 30. So this was all for today. I hope you liked the video. Thank you for watching this.